Just a short video on the somewhat interesting guts of this Flowtron bug zapper I just got. Interesting because of how simple it is. What it's doing is it's using this one component here as both the choke ballast for the ultraviolet bug draw lamp, which also provides warming heat for the octanol ore to attract mosquitoes, which is the important part and why I got this thing largely. And it also has this fairly loosely coupled secondary winding on the inductor, which is serving as the power supply for the killer grids. And so this would not make a very good transformer on its own. I would also not apply 120 volts straight to this, because the secondary is designed, or no, the primary is designed to be in series with that lamp, which is going to be dropping a good probably 40 to 50 volts. As you put this on straight 120 volts, it may burn up. It's certainly going to shorten its life. And a couple of interesting things about the construction of this component, both transformer and choke inductor ballast thing. It's got very small, or very narrow air gaps in the magnetic shunts, because these magnetic shunts are what accomplish the current limiting or power limiting on the secondary of these types of transformers. Very common in microwave oven transformers. You'll also see this in constant power auto transformer and a high leakage reactance auto transformer, and isolating high leakage reactance transformer ballasts in Canada, where the shell of the lamp holder has to be electrically grounded or, close enough to ground potential. And so what that's going to do is it means that this is largely going to function as an inductor with very poor coupling to the secondary power-wise. But for this application, you kind of want that, because you don't really care however many thousands of volts, or if it's limited to a couple of milliamperes of zappy current, because, all you want is a sufficient potential on those grids to kill bugs, which is, again, la raison d'etre of this thing. Another interesting thing about it is inside this potting, there's that blue cylindrical dingus, which is a probably 10 to 20 kilovolt rated, could even be 30 kilovolts, just because availability in this thing is not exactly super expensive. That could be functioning as an LC tank circuit to help with the ballasting characteristics of the lamp. So yeah, fairly interesting for something as simple as this is. And then, of course, this little glass component here, that is the starter glow bottle for the ultraviolet lamp. Now, contrast this with a more common thing for a lot of these, where the lamp and killer grid power supply are separate components. By the way, this is off, has been for days, so this is touch safe, because I've checked. Where this one circuit board has this side, which is a fairly typical resonant converter type electronic ballast for driving the, in this case, 40-watt ultraviolet lamp. So very typical, sort of a Royer-like converter, at least for ones that would use a transformer. This does not, this is an inductor. Where there's the power inductor, and then there's a separate base drive transformer here, that one with 3 windings. Then that, which is the diac used as a starting perturbation thing, so that this oscillator circuit is self-starting. Pair of reservoir capacitors, and 2 diodes, because this whole bit of the circuit is designed to work on about 300 to 330 volts DC. And so to make that work in 120 volt mains land, instead of having a straight up Grant's bridge, you just have 2 diodes, 2 electrolytics of the same value. They're both 10 microfarad, 400 volt, and you're good to go. Then there's an interference suppression capacitor, a varistor there, fusible resistor, This interesting bunch of stuff over here, there's 4 of these diodes that are functioning as the Grants bridge for this, which is actually very similar to a cold cathode fluorescent supply, and they may even be repurposing a cold cathode transformer, because that's certainly what this looks like, where the secondary is divided up into a bunch of different segments. That's to increase the dielectric breakdown rating of the secondary, because the secondary of this thing's operating at several kilovolts. That's also why there's a bunch of this elastic goo on both sides of the circuit board. But getting back to the diodes, there's a couple of other interesting things about it. And that is that they've got a pair of snubber networks in here, just to avoid killing these 2 transistors. But what's interesting is that they're using 1 in 4007s as the snubber diodes, because each of these, see, that diode's in series with this 300 ohm resistor, and that diode is in series with this 300 ohm resistor. It's another diode. Haven't traced the circuit out, but looks really conventional, but quite interesting. Also, it's another interesting thing about it that it's doing this pair of capacitors is there is that tertiary winding right there that's done with fairly few turns of wire, and one end of that is connected to the DC negative bus. The other end is connected to this pair of capacitors, one of which is tied to DC positive, one of which is tied to DC negative. And so, almost like they're using it as some kind of a tank circuit for waveform shaping, so quite interesting stuff in one of these things. And then, of course, this has a second board down here, which is simply serving as the light controlled switch, because this bug zapper can either be on continuously when energized, or it can shut off during the day. And the way that's accomplished is quite interesting. There is this external clicky switch, but this clicky switch doesn't activate any contacts. What it does is it blocks the cadmium sulfide cell that the photo switch uses when you want the thing to be continuously on. And that may seem kind of weird, but they've already got the photo switch built into the thing, and the advantage of this is that the spring retention mechanism for this clicky switch doesn't allow any water to leak into the electronics compartment of the bug zapper. And you know anything about electrical anything that's outside, water is going to leak. I don't care how good your seal is, especially in something like this, which is a consumer device which is built to a price non-standard.